So this is a short video on the editorial of Codeforces round 826 division 3. Let's start with the problem number B, funny permutations. So this problem we have to find a funny permutation. So what is a funny permutation? A permutation in which at least one of the neighbor of pi has the value that differs from pi by 1. So if some value is 5, so it should have the next value 4 or 6. Basically, the difference between them is 1. It can be one of its neighbors, either right neighbor or left neighbor. So we have to find a funny permutation. This question can be done by simple observations like, so one more condition, and that was the number on the ith index should not be I. So first of all, we can just take, let's see, if we have a permutation of 5, 1, 2, 3, 4 and 5. I think I should increase the size of this block to like 18 or maybe 24. So if we have something like this, and let's say 6 also, and 6 only, so then the condition is on the ith index the number should not be I. So here it can't be 1, here in this position it can be 2, or like in this position it can be 1, but it can't be 3 in this position. So we have to find such a permutation. So the basic observation is, what we can do, we can just take the last two numbers and put them in the front, like we can do 5 6, and then we can repeat 1 2 3 4. So this permutation satisfied all the condition, because every element has a neighbor that is greater that is having a difference of 1, like 5 6 is having a difference of 1, and all these things are having differences of 1, and none of the index matches. So this can be our answer, this will be our answer basically. So some edge cases are like, if the permutation is like 1 2 and 3, then we cannot have another permutation like that. Is because if we try to have 2 here, we should have 1 or maybe 3 here, but we cannot put, but if we just put, we can put 2 here, we can put 3 here, and we can just put 1 here. But the condition which is not satisfying is 3 and 1 are having differences of greater than 1. If so, we have to put a 1 here, but if we do so, we have to put 3 here, which will give the same value at the index number 3, that is 3. So if the permutation is of the length 3, then we cannot find a permutation. Otherwise we can find a permutation by using this technique, by printing the last two elements first and the rest of elements after that. So code for the problem is like this. First we define n and we take input of the n, that is the length of permutation. We check if n double equals to 2. Then we can just print 2 and 1, that is the answer of the permutation of length 2. And if the n is double equals to 3, then we can't print a permutation, so we print -1 and return. If these two are the edge cases, other than that we can just print our normal sequence that we discussed, like we can print n-1 then n, and we can print the rest of the numbers like this. So here it gives the correct output, and this was the problem number B. So here is the problem number C. In this problem we have to find the minimize the thickness. Basically we have given an array, we have to divide the array into some segments such that the sum of every segment is equals to are equal. Basically, like if this is the array is this, we can just break it into the array, like we can just let's see here, if the array is this, then we can break it into segments a1 2. Basically 1 2 is 55 and 45, and then 3 5, which is 30 40 and 50. Then the last segment is a 6,6 from left to right index, and the sum of every segment is equals to 100. So we can consider this segment, and we have to print, what we have to print is minimum thickness among all possible splits. So we have to split the segments in, we have to split the array into the segments, and we have to find the length of minimum length that we can have, which satisfies this condition. So if so the maximum, what can be the maximum answer? The maximum answer can be the length of the array, because if we just take one segment and that consists of the whole array, then our answer will be n. The answer cannot be greater than n. So the approach for this question is, so the logic we can apply in this one is, let's suppose the array is this one, and then what we can do, we can calculate the prefix sums. What we can do is we can calculate the prefix sums for this array. So what it will look like, so first it will be 1, then 3, first then it will be 3, and 3 plus 3 is 6, 8, 9, 11, 14. So we can just give some spacing here, like 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this will be a prefix sums. Now what our approach is like, first we will check this sum. Can we divide the array into the segments having the sum 1? Then we will check whether we can divide the array into segments having the sum 3. Then we'll check whether we can divide the array into the segments having sum 6, and so on. And while calculating this, if we are able to divide the segments into the sums, into the segments having the sum this, or having basically any of it, then we can just store the length of maximum thickness, the length of the length of the subarray, the length of the segment basically. Like if we divide it into three parts, we can just check the length of maximum segment among these, and we can find for the first one the maximum length of the segment if the subsegment of someone can be made, and if we can make the subsegments of, if we can divide the array into subsegments of sum 3, then we'll check what is the maximum thickness, what's the maximum length of a segment in this case. Then for all cases we'll check the length of maximum segments and we'll minimize that. So I guess we can look at the code and understand it better. So yeah, here in the code, first we declare the variable n. We take the input, that's the length of the sequence, length of the array basically, and then we can just find the prefix sums. We declare the variable sum, the sum 0 is equals to v0. Then we find the prefix sums. After that, we declared our answer as 1e18, that is the max value. We have to minimize it basically. So we'll run a for loop which goes from 1 to n, and from 1 to n we'll just check the value of sum I, basically the prefix sums. We'll just declare a variable z, count, and min. I'll tell you what these are declared for. Then we'll declare a variable j, and then we'll run a for loop which will go from 0 to n, and we will take a variable z and add to it the variable vz. And if this sum means the sum of the subsegment, so if the length of the length of the segment, if it is equal, we'll just check the count plus plus, which is the number of elements in that sequence, in that segment, and we'll check if z, basically this is the condition which I'll tell you later. And we'll check if z is double equals to sum. Then we have find a segment having sum is equals to sum I, basically the prefix sum array which we made. Then we can check if the sum is equals to I, then we can check the length of the segment, the maximum length of segment. And if at some point z is greater than sum I, then it's for sure that we cannot create that sum I. So we'll take the minimum is equals to 1e18 and break. Basically we cannot consider this case having the sum I as the sum, because when we are considering sum I as the sum, the z is greater than sum I at some point, so we cannot do that. And this condition is for the last case, when j is double equals to n minus 1. When we are at the last element, we should have z double equals to sum I, but if z is not equals to sum I, so again we cannot take the sub segment, basically we cannot take the segment, and again we will do m is equals to 1e18 and we'll break. At the when the for loop ends, we'll just do answer is equals to minimum of answer comma n. That is for sure the answer will be at max equals to the length of array, it cannot pass that value. It cannot be greater than that value, and at last we'll print the answer.